All right, ladies and gentlemen, set 64 is on complex fractions, and then we're just going to review complex numbers. Reminder, complex fraction is a fraction where the numerator, the denominator, or both have a fraction. So in the example, our first one here, just our denominator has a fraction, and in the second one, we have it in our numerator and in our denominator. But we've worked with these. We're just going to be seeing some that have them embedded with addition and subtraction. So here, the first thing we're going to look at is we're just going to start with the denominator here, and we're going to make it to have common denominators and add our like terms. So I need to put this and a C and a C. Whatever you do to the top, you got to do to the bottom. So now that denominator I can rewrite as AC plus B over C. Okay, I need to get that fraction out of my denominator. So to do that, I multiply the bottom and the top by the reciprocal. Everything's going to cancel in the denominator. In the top, we're also going to be multiplying. Okay, so now my problem looks like this. Oops, not equals. Now I have a fraction that I need to add to it, so I'm going to make common denominators. So I'm going to multiply by AC plus B, AC plus B. Now I'm writing out every single step. You aren't always going to need to write out every single step. Some of you are going to be able to jump right to things like this. And that's just fine. Okay. And since my terms have common denominators, I can write them all over the same thing. X AC plus BX plus C all over AC plus B. This is my answer. It's a little bit longer, but it's not something we can't handle. The last thing you would always want to check for is, do you have any like terms in the numerator that you can combine? And then you would look and see, do I have anything out of all of the terms that I can cancel? You shouldn't, but if you do, we will take care of that. Okay, so if we look here, I want to multiply by my A by B, okay? And I'm going to leave my first term. So I'm going to write this all at 1 over B. Okay, now I'm going to multiply by the reciprocal in the numerator and the denominator. Everything cancels down there. And now I'm just going to be adding two fractions. Now when I add the two fractions, I need to get common denominators here. And if I see this, to get a common denominator, I always have to multiply by something. So I'm going to have to multiply this entire thing by C. I'm going to have to multiply this entire thing by A plus B plus 1. Okay, and then I do that in the top. And I multiply this by C also. I'm going to distribute here because it might get me some like terms. So 4AB plus 4. And then in my second term, it's going to become BC. And then my denominator is all the same. And I'm going to leave it unfactored. Or factored, sorry. Do I have any like terms in the numerator? Nope. And so there's nothing that I can cancel out of all of them. All right. Let's look here. Actually, I'm going to just give you the answer to this one, and I want you to try this out by yourself. You'll see when I get to this point, a lot of you will get here, is that I have a y that I can cancel out of every single term. Okay, so then I'm left with ma plus 1 plus x over ay plus 1. You cannot cancel out your plus 1s on the top and the denominator because they are being added to something else. So here's where my answer is. Okay, if you go ahead and try this one, I'm going to give you just the answer here. And we get x squared plus 2x plus, or over x plus 1. This one is very similar to the previous one where we had some canceling to do. Okay, so let's just talk briefly about our complex numbers. We've seen problems like this before. We had you memorize, asked you to memorize the little chart. But as long as you know this, you're good. We also talked about in class typing it into your calculator. Now you know the I button is above your decimal place, but I will say you're going to want to change the mode. If you scroll down, you'll see yours is probably in the real. If you go over, now it's going to be in complex. This will give us answers in complex. Okay? So I can type that all in and hit enter and it does the work for me. So pretty slick. So then this one ends up being 0. Okay, so if we look here, I'm gonna go ahead and take a moment and slide this over and I'm going to type this in for you. Okay, so just take a look and make sure that I have that all typed in there correctly. Watch when you are doing this that you aren't getting everything all under one big square root, that you're actually coming out when it becomes next time. So we just hit enter, does the work for us, and the nice thing about now we have it in complex mode is it actually gives us the answer back in complex. Okay, then we see that we can FOIL things that are complex numbers. FOIL, or you can use your box method. Either one is going to work just fine. Okay, I get negative 16i and 8i squared. Okay, and then you look for like terms. Okay, and then the other thing to keep in mind is that we have talked about, we had in our video when we were introduced to imaginary numbers, that I squared turns into a negative 1. So this becomes a negative 8. We have a few more like terms, so we get negative 22 minus 9i. Okay, you could type that into your calculator also, but this one's easy enough that you can do it without. Okay, so if we go ahead and FOIL again, we get negative 12. Negative times the negative turns into a positive 28i. We get a negative 6i, and negative times the negative turns into a positive 14i squared. Remember, I squared is going to become negative 1, so I can think about this as negative 14. So I add my like terms, and I get negative 26. Now, your real part of this complex number comes first, and then your imaginary part is second. And that's all we have for you, ladies and gentlemen.